Okay, this is lesson 5.2, and in this lesson we're going to do an analysis of the parabola in the x and y axis. And we're going to look at all of the features a parabola can have. The first one is called the axis of symmetry. Unlike the human face, the parabola is truly symmetrical. If one arm of the parabola is reflected in the mirror line, or the axis of symmetry, the other arm is created. Because the axis of symmetry is a vertical line with an undefined slope, the equation is always going to be x equals something. For the parabola we're going to draw, we're going to write what the equation of the axis of symmetry would be. So we're going to graph a couple points here. If you look, we have our axis right through the middle. I want to graph a point at 2, -1, so right there. I'm going to graph a point here, and over 1 and up 3 more, over 1 and up 3 more. So these are going to be my points for a parabola. I'm going to connect them and draw the parabola. I just made this parabola up. It's not anything specific. The axis of symmetry would be the vertical line that splits the parabola in half. Now the thing about the axis of symmetry is always going to split the parabola in half and go through either the point at the bottom of the parabola, or if it was flipped the other way, the point at the top of the parabola. So at this point right here, our vertical line is going to go through it. So we draw our vertical line straight up and straight down. And if I highlight it, there's our axis of symmetry. And the equation of our axis of symmetry is always x equals, and we just look at where our line crosses the x-axis. If that's 0, because it's in the middle, that's 1, that's 2. Our axis of symmetry would be x equals 2. So notice it splits the parabola right in half. This arm, if we reflected it across, would give us the second arm of the parabola. This point is 2 spaces from the line, and this point is 2 spaces from the line. This point's 1 space from the line, so this point's 1 space from the line. This point's on the line. If we had another point somewhere over here, it would be 3 spaces from the line, so there would be another point 1, 2, 3 spaces from the line over here. All right, that's the axis of symmetry. The second feature is called x-intercepts. The x-intercepts of the parabola are also sometimes called the zeros. And there may be 0, 1, or 2 x-intercepts. And I'm going to show you what I mean by that. X-intercepts are just where the graph crosses the x-axis. So if our x-axis is, try to make this a little bit bolder for us. If this is our x-axis, we're going to draw parabolas that cross it 0 times, 1 time, and 2 times. So there's our x-axis, a little bit darker. So this example, I'm going to do no zeros. So I have to draw a parabola that doesn't cross it. So I'm going to start above the axis, and I'm going to go like this. See, this parabola does not cross the x-axis. And if I draw another one, let's go below this time. There's another parabola that does not cross the x-axis. So we either have to have a parabola that's above the axis and opens up, or below the axis and opens down, and it will have no zeros, no x-intercepts. If we want our parabola to have 1 0, that means that our point at the bottom or point at the top has to be on the axis. Just the one point has to be touching. So we have to have something that looks like this. Or something that looks like this. There's that one point right on the axis. The most common is 2 zeros. That's where we have a point down here. And we open up. Or we have a point up here. And we open down. So 1 0, 1 1. 2 zeros, we got one there, one there, one there, one there. And no zeros. We don't cross. Y-intercept. The neat thing about the y-intercept is there's only one scenario. The parabola has to cross the y-axis. Now, depending on how big your graph is or scale, it might not cross until like way up here, which it'll be hard to tell what the y-axis or y-intercept is, but it's still always going to cross. So I'm going to draw two graphs. Let's say we're going to cross here. There's one parabola. And let's have another one that crosses, oh, I don't know, right here at the bottom. Didn't really draw a very good curve there, but we've got a y-intercept here and a y-intercept here. Two different parabolas. The first one, well, that point would be 0 and 4 because we're up 4, and this one would be 0 and -6. So we have 2, 0, 4, and 0, -6. So, axis of symmetry, the line that splits the parabola in half. X-intercepts, where the graph crosses the x-axis. Y-intercepts, where the graph crosses the y-axis. Reflected point. The reflected point is any point on one arm that can be reflected in the axis of symmetry to create a reflected point on the other arm. So let's say we have an axis of symmetry. Do 1, 2, 3. Draw an axis of symmetry right here. And let's say we had a parabola and we have 1/2 of it. Let's say we knew that this was half of our parabola. How do we get the other half? Well, the other half would be somewhere over here on the outer side of the axis. So we'd take our first point and we would reflect it. If it's 1 away from the axis, we'd have another point right here, and that would be a reflected point. If we have a point up here, we could go 1, 2, 1, 2, and we'd have another point. That would be a reflected point. And now if we connect the dots, we can complete our parabola. So there's our reflected points. So if you ever know one dot on one side of the axis, you can find another dot on the other side by reflecting it across the axis. Direction of opening is something that we talked about in the first lesson. The sign in front of the x squared term determines the direction of opening. The parabola may open up when the sign is positive. So for example, if we have like x squared term, or say we have 2x squared, or maybe we have a fraction in front of x squared. As long as it's positive, we're going to get a parabola that opens up. So we get something that looks like this. Doesn't matter if you draw the points specifically, I'm just being particular. You just need to draw a curve that points up. If the parabola opens down, the sign will be negative. So in our equation, we'll have something that looks like this: negative x squared, or negative 6x squared, or negative 1/2 x squared. If the number in front of the x squared is negative, we're going to open down. So let's start on the axis, and if we open down, the sign in front of x squared would be negative. So this is up, and this is down. All right, last property, I think. Yes, last property. Vertex. The vertex is the point that's either at the top or the bottom of the parabola. Now the parabola changes direction at a point called the vertex. It's the point that's on your axis of symmetry. So the vertex can be the top of a mountain, or a max point, or it can be the bottom of a valley, or a minimum point. The axis of symmetry will always pass through. The vertex. So I'm going to draw a point here. I'm going to go over 3 and down 3, 1, 2, 3. And I'm going to have my parabola go up. All right, so let's get the curve. There we go. So if we look, the axis would be right here, and this point would be the vertex. And this point would be negative 3, negative 3. If you read the coordinates off, that's 0, so 1, 2, 3, 1, 2, 3. Perfect. And this means we have a minimum value of negative 3 because it's at the bottom. And the axis goes through negative 3 as well. The minimum value will always come from the second part of the vertex. The first part of the vertex will be your axis of symmetry. All right, so the vertex is just a point. It can also be a maximum. So let's draw a point here. We've got here, 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 here. Let's draw a curve. And there we have it. We have a maximum vertex this time. This time our vertex is, let's read the coordinates off, over 1, 1, 2, 3, 4, 5, up 5. Our vertex is 1, 5. So that means we have a maximum value this time. And that's because the second number of the vertex is 5. All right, that's all the properties of a parabola. So let's see if we can put this to practice. Here's a parabola. We're going to complete an analysis. We're going to draw the axis of symmetry and state the equation. We're going to find the zeros or x-intercepts. We're going to find the y-intercept. We're going to do the direction of opening, up or down, and we're going to do the vertex. So let's get started. Axis of symmetry goes right through the middle of a parabola. So it's going to go right here. And if you remember, the axis of symmetry's equation will always be x equals wherever it crosses. So this time it crosses at 2, so we have x equals 2. X-intercepts, well, let's look where it crosses the x-axis. 1 point there, 1 point there. So we have x-intercept, and we have another x-intercept. And we write the coordinates down. Well, this one would be 1, 2, 3, 4, 5, and y is 0. This one would be -1 and 0. So there we go, -1 and 0, 5 and 0. Draw and state the y-intercept. We cross the y-axis right here. And that would be 0 for x and -3 for y. The direction of opening, our parabola's opening is to the top, so it's up. And the vertex would be right here. And the vertex is 2 for x, -5 for y, 2, -5. All right. There's 2 more examples here. I'm going to leave them for you to try, and you can check your answers on the course website. That's it for our second lesson in quadratics. Thanks for watching, and I'll see you in 5.3.